So let's take a look at the following problem. We're asked to find the length of a missing leg in a right triangle. We're asked specifically to enter our answer as an exact value. That means no decimal approximations. In short, that means either we're going to have a straight up integer answer or something that probably has a square root. So let's go about solving this problem. Our first step is to recognize that, in fact, we have a right triangle, and we know that because two sides are perpendicular. And in the right triangle, we have three sides. The two sides that are connected to the right angle are called legs, and the opposite side, the side opposite the right angle, is called our hypotenuse. And so this problem is very nicely set up for us to use what's called Pythagorean Theorem. And Pythagorean Theorem tells us that if we take the length of one of the legs and we square it, and then we take the length of the other leg and we square it, that will always be equal to the length of the hypotenuse squared. Or, if we like, a squared plus b squared equals c squared. So in our problem, we have to identify all of our pieces. Well, we're looking for one of the legs, which is x. We happen to know the other leg, which is 13. And we also happen to know our hypotenuse, which is 15. So if I apply Pythagorean Theorem to my right triangle, I get the equation that x squared plus 13 squared equals 15 squared. We can simplify, and that gives us that x squared plus 169 is 225. We can continue to solve, so we'll subtract 169 from both sides. That gives us that x squared is simply 225 minus 169, or 56. Now we're almost finished. We have solved for x squared, but now we need to go back and actually find just the representative for x. And how do we do that? Well, we take a square root. X squared equals 56 is the same thing as stating that x equals the square root of 56. We're only going to consider this positive value because we're talking about the length of a missing leg on a right triangle, so I only have to worry about the positive square root of 56. That is an exact value, and we could stop there. But if we want, we can actually simplify one more step mathematically, so let's talk about that. So in math, when we get square roots, we say something about simplifying the square root, and to do that, it means breaking it down into simpler forms or simpler factors. If we take a closer look at 56, we know that 56 is equal to 8 times 7. And specifically, I know that 8 can be written as 4 times 2, and then I have times 7. Now, what does that allow me to do? Well, if you take a close look right here, what is the square root of 4? Well, I notice that is something that I can actually calculate. The square root of 4 is just 2, but then I'm left over with the square root of 2 times 7, and that's 14, and I can't take a square root evenly of square root of 14, so I leave it as 2 times the square root of 14. So if you like, you can either leave your answer as square root of 56 or 2 times the square root of 14. Anyways, that's how you find an exact value using Pythagorean Theorem. If you have any questions, please let me know.